Let's dive into the shortest notes on the electricity class 10. So this is a quick revision. So first of all, we have 1 coulomb. The charge of 1 coulomb is 6.25 10 to the power 18 electron charge. We need to remember this. Then we have potential difference, that is V. V is equal to W by Q, that is work done by quantity of charge moved. And we represent this potential difference as V, and it is volt. That is the SI unit of this potential difference. 1 volt equals to 1 joule per coulomb. Then we have this I equals to Q by T. This I equals to Q by T is current equals to Q by T, that is Q is the coulomb charge flowed, and this is the time, that how much time the charge flowed. Then we have the most important thing we have, that is our Ohm's law, which is very much important. So Ohm's law tells us that current is directly proportional to volt, that at a constant temperature, and volt is directly proportional to I, that is the vice versa. So we have three major formulas for the Coulomb Ohm's law, that is V equals to IR, R equals to V by I, and I equals to V by R. And here R is a constant. R is a constant means R will not change. Now then we have resistivity and resistance. So resistivity is represented by rho, that is a Greek letter, and resistance is represented by R. So resistance equals to rho L by A. Now here some people confuse in the A, that what is this A? Is this ampere or what? So A is basically area of cross section of conductor. Now what is this area of cross section of a conductor? So imagine it like that, that if I cut a copper wire perpendicularly and excluding the insulation, the surface area of that copper wire through which the electricity will pass will be called the cross section of conductor. Okay, so basically it is the surface area of the conductor. Then we have, so from this formula we can found the resistivity, that is Ra by L, that is resistance multiplied by area of cross section by length of wire. L is the length of wire. Now in a specific condition, that is if area is 1 and length is 1, then we will get a very interesting thing, that is the resistance will be its resistivity, and vice versa, resistivity will be its resistance. Moving to our next thing is factors affecting the resistance of a conductor. So what factors affect the resistance of a conductor? So there are four main factors that affects the resistance of a conductor. That first is R is directly proportional to length. That means the length, as the length increases, resistance also increases. As the length decreases, resistance also decreases. R is directly proportional to, inversely proportional to the area of cross section of conductor. Means if the area of cross section decreases, the resistance will increase. That means a, wire with smaller diameter will have a high resistance, and a wire with a larger diameter will have lower resistance compared to a small diameter wire. Then we have R is directly proportional to temperature. Pure metal, some pure metal change it their resistance based on the temperature. So that is what. And then fourth is the nature of material of conductor, that is uh, the material itself can vary resistance. Then we have electric current represented by P. So there we have three formulas, that is P equals to VI, that is voltage potential difference times current. Then we have P equals to I square R, and P equals to V square by R. R here is resistance, not resistivity, and this is not rho. That is electrical current. And we have a sub thing in this, that is electrical energy. Now there is electric current and there is electrical energy. We'll discuss the difference later. So this electrical energy is basically Pt, and here P is this basically electric current into times T. So we can use any of this formula here. Then we will get different formulas, for example VIT, or we will I square RT, or V square by RT. So we will get different formulas based on the uh, what the question says gives. Then there is another formula, that is heat produced, and it is the last thing, and it is also important. So heat produced is equals to I square times R times T. Here I is current R is resistance and T is the time for what the current has been running through it. Or we can use say that heat produced is basically electric current times time, so it is PT also. Basically this I square R can be represented as this P as well as. So from this formula we can get that heat is directly proportional to I square, heat is directly proportional to resistance, and heat is directly proportional to time. That means the amount of current passes through the conductor will affect its heat production, the resistance will affect its heat production, and the time for which the electric current has been running is also a factor of the heat produced. Okay, and you can take the screenshot of it and you can revise it anytime. So this is where that's all, and we'll discuss the topics later on.